Hi Falcons. The purpose of today's lab is going to be to perform a reaction to determine a theoretical yield for a product. The reaction that we're going to do today is a single replacement reaction. It's a single replacement reaction between aluminum, which I have here in an aluminum wire, so a silver solid aluminum wire, and copper 2 chloride. Copper 2 chloride is this kind of grayish brown crystalline powder, okay? And I'm going to perform a reaction between those two that we're going to produce these two products, copper solid and aqueous aluminum chloride. What our goal is going to be is to figure out which of these two, the aluminum or the copper 2 chloride, is our limiting reactant, and then using that limiting reactant, determine our theoretical yield, or the maximum possible amount of the copper that we can produce. So to begin the lab, what I've done is I've measured the mass of this copper 2 chloride. The mass of the copper 2 chloride, which is written for you here, is 1.00 grams. The first thing I would like you to do is to write down your qualitative observations of these crystals. So take a look at them and write those down on your lab. Were you able to get it? Next, what I'm going to do is I'm going to create an aqueous solution, meaning I'm going to dissolve it in water. So what I'm going to do now is I'm going to take a test tube and fill it with distilled water. And then I'm going to take my 1 gram of copper 2 chloride, it was exactly 1 gram, and pour it in there, and then using my stirring rod, I'm going to mix it to dissolve it. You'll notice something interesting that happens to copper 2 chloride when it becomes dissolved. The copper ions actually turn the solution blue, which you can see now. Okay? Your next step is going to be to make an observation of this solution. So the solution that you see, that's the aqueous copper 2 chloride. This is going to be your first reactant. Your second reactant is going to be your aluminum wire. So I'm going to take that piece of aluminum wire and I'm going to put it onto my balance. That aluminum wire has a mass of 0.64 grams. Okay? Now what I'm going to do is I'm going to take that aluminum wire and I'm going to insert it into the copper 2 chloride and it's going to begin to react. Now, as it's beginning to react, you're going to observe what's occurring as it's reacting. And I'm going to hold it up, and what you can see, if you come in closely, you can see that it's starting to turn brown. There's a little bit of bubbling that's occurring, and there's a brown substance forming on the outside of the wire. That's the reaction on the data you should be collecting right now. You can see little bits of bubbles forming on the wire itself, and a brown substance, a reddish brown substance forming on the wire. So record that data, that qualitative data, in your observations. Now, in lab, what we would have done now is this would have been the end of day 1. We would have let this test tube with the wire sit overnight. And then at the beginning of day 2, after nearly 24 hours of reaction time, what you would have seen is this. And there's a lot of important details that you can get from this. The first being the color change. Notice that it was blue before, and now it's clear. That should indicate something to you about chemicals that have run out in this reaction. You can also see our product. That brown substance, when given 24 hours, you formed quite a bit of it. And this is the next part in the lab where you're going to record your observations of the completed reaction between aluminum wire and that aqueous copper 2 chloride. Okay, and you're going to record that here. The next thing that we're going to do is we're going to have to acquire our copper solid so that we can measure it and get its mass. So what I'm going to do is I'm going to take this and I'm going to carefully remove the wire and I'm going to put it into an evaporating dish. Now prior to doing that, I'm going to get the mass of this evaporating dish because we'll need it for later. I've recorded that mass for you later in the lab. Okay? I've recorded that mass for you later in the lab. So then what we're going to do is the following. I'm going to take the wire and I'm going to carefully remove the wire, and I'm going to save this for later, and then what I'm going to do is I'm going to decant some of this liquid, and then I'm going to put the copper into that evaporating dish. So what I'm doing now is just pouring off some of the liquid, and then I'm going to put the copper into the evaporating dish. And you might need to, in your lab, add a little bit of extra water just to get that copper to pour into the evaporating dish. Now what I'm going to do is using a pipette, I'm just going to suction off the additional water. So if you look here, you can see that you have your copper along with a pretty fair amount of water that's in that dish. And what I'm going to do is just simply suction off the rest of that additional water. Now we have some fairly wet copper particles. And what I'm going to do with them is I'm going to place them onto this drying apparatus. What I have here is a beaker with boiling or nearly boiling water that's going to serve as like a hot water bath, a steam bath, if you will, to heat this. I'm going to place this on top using crucible tongs. And then I'm going to let it heat. Now what you would be doing in class as it's heating is simply kind of moving it around and watching the water. The water would be kind of boiling and bubbling in here, and you're just going to keep moving it around and moving it around as the water dries away. We would do this for 10 minutes. After 10 minutes, what we would end up with is a product that looks like this. It would just continue to dry, and I would continue to move it around and allow it to dry until we just had a dry copper product. This would be the actual yield of copper that we've created for this lab. I'm going to take this, and again, there's a place on here to observe your dry copper product, and now I'm going to weigh this evaporating dish with the copper in it, and I've got the mass of the evaporating dish when empty, and the evaporating dish plus the copper, so now you can figure out the mass of copper that was actually produced and record your observations here. After this point, we should have all the data we need to determine a theoretical yield and a percent yield for this particular reaction, as well as a limiting reactant and an excess reactant. One other point that I forgot to mention is I did also want you to have a second to look at the aluminum wire after the reaction. This is the aluminum wire once it's done. You can see that it's no longer shiny and it's pitted. And I'm also going to record the mass for you on your data table as well, so you can see the mass of aluminum before and after. You should notice that we have aluminum wire left over, and that should mean something to you as you're completing the lab. At this point, you should have all the data that you need to complete the lab write-up. The remaining parts of the lab will ask you to use your qualitative information, so what you observed, to predict a limiting and excess reactant and tell us why. You can then use the starting amounts of copper 2 chloride and aluminum wire to calculate your theoretical yield. That'll take 2 different reactions, 2 different equations, 2 different calculations to do that. And you should be able to figure out which one is the limiting reactant and which one is your correct theoretical yield. and then there's 2 additional post-lab questions for you to answer. Thanks for your time, Falcons. Have a great day.